So today we will be seeing about matched filter receiver, practical approach, practical case. Generally on the digital communication systems we know the pulse rate and the sampling and the pulse duration rate நமக்கு தெரியும். So இதில் முக்கியமான digital noise ன்னு சொல்லுவாங்க. So we call it as digital noise. How to minimize the digital noise at the receiving end. So அதுக்கு என்ன பண்ணலாம்னா noise. So you are tapping the signal only at the particular point, sampling point. Other than that, the gain has to be zero. That's the core idea. என்ன சொல்ல வரேன்னா அந்த எந்த இடத்துல சிக்னல் நமக்கு அந்த டைம் அரைவ் ஆகுதோ அந்த இடத்துல மட்டும் சர்க்யூட் ஆம்ப்ளிஃபை பண்ணோம், மற்ற டைம்லலாம் சர்க்யூட் ஆஃபில் இருக்கணும். இது ஒரு ப்ராக்டிக்கல் சுச்சுவேஷன். அப்போ நம்ம நாய்ஸை மினிமைஸ் பண்ணலாம். அதுக்கு நம்ம ஆப் ஆம்ப் வச்சு ஒரு சொல்யூஷன் இருக்குது, அதை தான் நம்ம டிஸ்கஸ் பண்ண போகிறோம். Now I will draw the circuit. First you have an op amp, say negative, positive with a gain. Say this is RF R1. Okay, now this is grounded. So மற்றதெல்லாம் உங்களுக்கு தெரியும், இந்த இடம் ப்ளஸ் விசிசி, இது மைனஸ் விஇஇ. ஓகே, இப்போ நான் இது வந்து ஜென்ரலாக இது 100K, இது 1K அப்படி போட்டேன்னா, if a signal is arriving at this point, gain உங்களுக்கு தெரியும், because this is 0. So this is V in, this is 0. Since this is 0, this is also 0. The current here will not go into the op amp. Why? The input impedance of the op amp is infinity. Therefore, this current and this current has to be same. That is, this is IF. Okay. Now this is incoming current. Now we have Vout. So at this junction, if you see, the incoming current should be outgoing current. The incoming current is V in minus 0 by 1K. Okay. Or I can call it as R1. This is the current is equal to outgoing current. Outgoing is 0 minus V0 by RF. Now the gain is what? V out by Vin. That is the gain. So you bring this RF and move that V in that side. So RF by R1 is equal to minus V out by Vin. Now multiply by I minus 1. So V out by Vin is AV is equal to minus RF by R1. See, this minus sign indicates that it's reversing the phase. Okay, otherwise if you take the magnitude, the gain is RF by R1. That's the meaning. Suppose if it is 100K and this is 1K, the gain is going to be 100. This minus sign indicates phase reversal. Okay, so in the circuit it has a gain of 100. What is the problem? If a digital signal arriving at this point, okay, now assume that a digital signal is expected to arrive. We won't get a digital signal rightly like this. It is being modulated in different formats, ASK, FSK, PSK, so in so many formats. But assume that I am using a square wave, and once again I am expecting another signal after some period. This is one time period. Afterwards, once again a bit of information is expected. Now what we do is we put the best sampling time. Okay, it's the middle of this, and once again the sampling time receives like this. We know this time also. Okay, between these two sampling time. Okay, now if that is the case, what should be done now? If you don't modify the circuit, what happens is, other than this time, noise will enter through the circuit with the same 100 times. 100 times the noise also gets magnified. The idea is we have to minimize that noise signal. So what we do is, you put a CMOS switch here. So this is CMOS switch and a control signal. This is control signal you are giving. So this is control signal. Control signal 1. That is, the idea is, at the sampling point you have to close this switch. So you will get that gain. Other than the sampling point, the switch has to be opened. So some intelligence is required for controlling this CMOS switch. So basically this is made of CMOS switch, and you see that the CMOS on resistance is very minimal. That's how you have to choose, and you can, there are variety of CMOS switch, and you have to choose the proper switch. And this control signal comes from the microcontroller. Okay, so microcontroller now notes where to put this signal on and off. When it is on, the circuit is closed. When it's off, the circuit is open. Okay, this is one way of minimizing the circuit, minimize the noise. Next, what we can do, the other possibility is you can put a switch in parallel with 100K. Okay, this is once again a switch, CMOS switch. Okay, now this will have a control signal here, and this also comes from, this is control signal, I am calling it as 2. This also comes from microcontroller. So the idea is, when the signal is expected to receive at this sampling point, you close the switch and you open this second switch. So at the sampling frequency, at the sampling time, I am calling this as switch 1 and this as switch 2. Okay, at TS, switch 1 and switch 2. Switch 1 you close, switch 2 open. So you have maximum gain, that is 100 times the signal is getting amplified. So when out of after the signal, you have this time where the noise is likely to, during the off time, the noise is likely to enter the circuit. So we have to reduce the gain to 0. So what you do is, first step, at off time, so I call this as on time, T on. At T off time, what you do is you open the switch S1, so this will become open, so the signal cannot enter. But due to the resistance and a small strip of wires, copper wires and other things, by chance if the noise enters at any one of the material contact, then in that case the noise has to be reduced. So what you do is you close this switch, that means switch 2 is closed. Okay, so what happens if this is closed, then the gain is going to be 0 because it won't get magnified. So by this, what we can do is we can minimize the noise signal in digital processing systems. So generally we need a microcontroller. You can assign 2 port pins, one for this control signal, so this will go for say switch 2, and this for switch 1, and we know at which point the signal is expected to come, and that information is given to the microcontroller. Okay, basically this is a microcontroller, so that knowledge has to be provided to the microcontroller, then only it can actuate the signal at the operation of switch 1 and switch 2. So for knowledge of the incoming signal, we have synchronous circuits, okay, that it can synchronize the switching time. The circuit will synchronize exactly at the on time, and that information can be sent to the microcontroller, and immediately microcontroller knows at which point it has to go for on and off at these 2 pins of a particular port. Thereby we can reduce the noise in the system, okay, by doing this. Now the important point here is, if you don't connect these 2 switches, then the noise also likely to amplify 100 times. So to minimize that, we should make use of these switches. One serious problem about using the switches is you have to see that the on-off switching also will rise to spurious signals. So in that case, the damping of the oscillations has to be very fast, and it has to go to 0. That's why I told you, while choosing CMOS switches, you see that it goes to 0 within a short period of time. Okay, that's all about reducing noise in digital receiving communications systems. Hope you might have understood how a matched filter receiver works practically at the output side. Mostly this kind of circuits are integrated within the IC itself. Okay, but in theoretically you must know what is the simple concept behind the working principle of matched filter receiver. Thanks for your attention. Thank you. Nandri.